So welcome to this lesson on line integrals. Today we will be learning how to evaluate problems on line integral, and these also include parametric equations and working with the cross product. So coming to the first question, if f equal to x squared I plus xyj, evaluate integral over c f dr from 0 0 to 1 1 along y equal to root x. So y equal to root x means y squared equal to x. So differentiating, you get 2y dy equal to dx. So f dot dr will be x squared dx plus xy dy. And what is dy? You can, instead of dx, you can put 2y dy. And x will be y squared. So x squared will be y raised to 4 2y dy plus y cube dy. So we are basically converting everything to y, one variable. So this becomes 2y raised to 5 dy plus y cube dy. So integral over c f dr will be integral 0 to 1. Why is it 0 to 1? Because x and y lies between 0 to 1 1. Integral 0 to 1 2y raised to 5 dy plus integral 0 to 1 y cube dy, that is 2y raised to 6 by 6 within the limit 0 to 1 plus y raised to 4 by 4 within the limit 0 to 1, and you get it as 7 by 12. Coming to the next question, find the work done by the force F equal to 3xyi minus yj plus 2xzk in moving a particle around the curve x squared plus y squared equal to 4. So this is a circle, and what is the parametric equation of the circle x squared plus y squared equal to 4? It is x equal to 2 cos theta, y equal to 2 sin theta, and z is 0 here because we are in 3 dimensions. Theta lies between 0 to 2 pi. So dx becomes minus 2 sin theta d theta, dy is 2 cos theta d theta, and dz is 0. So note that we have to calculate dx, dy, dz also in terms of theta. So now work done will be integral 0 to 2 pi. Why? Because theta lies between 0 to 2 pi. 3xy, that is 3, 2 cos theta, 2 sin theta, dx is minus 2 sin theta d theta, minus integral 0 to pi, y is 2 sin theta, dy is 2 cos theta d theta, and dz is 0. So this becomes integral 0 to 2 pi minus 24 sin squared theta cos theta d theta minus 2 integral 0 to pi sin 2 theta d theta, because what is sin 2 theta? 2 sin theta cos theta. Now here we can make a substitution, put sin theta as t. So cos theta d theta is dt, and what do you do next? Whenever you make a substitution, you have to change the limits. So when theta is 0, t is 0, and when theta is 2 pi, also t is 0. So this entire integral becomes 0. And this becomes minus 2, integral of sin 2 theta will be minus cos 2 theta, though the minus will cancel out, cos 2 theta by 2 within the limit 0 to 2 pi. So when I substitute, I get cos 4 pi minus cos 0, which is 0. So work done is 0. Coming to the next question, if a equal to 18 cos 3ti minus 8 sin 2tj plus 60k, v represents the velocity which is 0 at t equal to 0, r represents the displacement which is 0 at t equal to 0, find r at any time t. So a we know is d2r by dt squared, which is 18 cos 3ti minus 8 sin 2tj plus 60k, and a is, what is a? d dt of dr by dt, that is d2r by dt squared. So dr by dt will be integral of this, that is 18 sin 3t by 3i plus 8 cos 2t by 2j plus 60 squared by 2k plus c. C is the constant of integration, and your v becomes, what will your v be? 6 sin 3ti plus 4 cos 2tj plus 3t squared k plus c. Now going back to the question, you are given that v represents the velocity which is 0 at t equal to 0. So at t equal to 0, what will v be? 0. So substituting here, you get 0 equal to 4j plus c, because cos 0 is 1. So c is minus 4j. And now what do? We substitute this c for v. So v becomes 6 sin 3ti plus 4 cos 2tj plus 3t squared k minus 4j. And v is dr by dt. So dr by dt becomes 6 sin 3ti plus 4 cos 2tj plus 3t squared k minus 4j. Now how will you find r? Again integrate. So when you integrate this, you get minus 6 cos 3t by 3i plus 4 sin 2t by 2j plus 3t cube by 3k minus 4tj plus d. So here d is the constant of integration. And what happens when t equal to 0? R is 0. This is given to you. So 0 will be minus 2i. All these terms become 0 plus d. So d is 2i. So what will be your r? 2 minus 2 cos 3ti, which is 2 because d is 2, plus 2i plus 2 sin 2t minus 4tj plus t cubed k. So we have just taken the terms in ijk together and got r at time t equal to 0. Next, if f equal to xyi minus zj plus x squared k and c is the curve x equal to t squared, y equal to 2t, z equal to t cubed, from t equal to 0 to t equal to 1, evaluate integral over c cross product of f with dr. So first we calculate cross product of f with dr, that is ijk. Your f will be x is t squared, y is 2t. So what will xy be? It will be 2t cubed, and z will be minus t cubed, and the x squared will be t raised to 4. Dx is 2t, dy is 2, dz is 3t squared, and taking the cross product you get I times minus t cubed into 3t squared, that is minus 3t raised to 5 minus 2t raised to 4i minus j times 6t raised to 5 minus 2t raised to 5 plus k times 2t cubed plus 2t raised to 4. So when you simplify f cross dr will be, so this is f cross dr, and what will be integral over c f cross dr? T varies from 0 to 1. So that will be integral 0 to 1 of this. Minus 3t raised to 5 minus 2t raised to 4i minus 4t raised to 5j plus 4t cube plus 2t raised to 4k. So integrating you get minus 3t raised to 6 by 6 minus 2t raised to 5 by 5i minus 4t raised to 6 by 6j plus 4t raised to 4 by 4 plus 2t raised to 5 by 5k within the limit 0 to 1. And when I substitute within the limit 0 to 1, you get minus 9 by 10i minus 2 by 3j plus 7 by 5k. So that concludes this lesson, and we have learned how to calculate problems on line integrals. We have also learned how to use parametric equations and cross product. So thank you.